again, we will speak about footwear manufacturing. And here you will have some nice YouTube videos. So if you have time later, if you have a break and drink some tea, so it's nice to look to a shoe manufacturing company. You will see easily a shoe is a complicated thing from my point of view. What you see, it is exactly leading to our point where we can identify VOC emissions. So very often you have the adhesive glue or gluing activity, where you glue different parts together, and finally you will have a whole pair of shoes. So and such a shoe exists of a lot of parts, we will see. So the basic is this ID directive you have already heard. Just for remembering now for today, what is this activity footwear manufacturing? Here, I think every word is very important. You will find in the definition any activity of producing a complete, that's very important, that word, complete footwear or parts, therefore. So you have, you will fall under that activity if you consume more than 5 tons per year on solvents. I will explain what solvents are and what does it mean. At the beginning, I want to point out here the cleaning of the equipment. For example, if you're using solvent, that you must consider to the footwear manufacturing activity. So in other words, if you have cleaning operations, for example, from some rollers or some spray equipment, you use organic solvent. So that quantities that will be added to the VOC consumption of the footwear manufacturing. Here, I want to point out that the emission limit value you will see in 1 minute is referring on the complete pair of shoe. What does it mean? And that is now very specific for the shoe manufacturing. Nowadays, very often some, let me say, preparation gluing steps from the upper or from other parts are outsourced. So in former times, a whole pair of shoes was manufactured, but nowadays, some of that gluing activities now are done by suppliers. So that means it's clear, if something happened and the shoe is manufactured in the final step, in that company cannot use the whole VOC total limit value, because it's clear, because some parts are not done in that company. They are done at the pre-suppliers, and so the pre-suppliers must inform the manufacturer, who is doing then the whole or the final part of the complete pair of shoes, and that emissions must be subtracted from the total emission limit value for this final, let me say, gluing installations or footwear manufacturing installation. Because you are not doing, I mean, the whole complete pair of shoes. I mean, you do this, but if some parts are done before by other operators and other pre-suppliers, then you cannot use the whole VOC value for your installation. So that can be a little bit complicated, and it's important that you then have to inform your inspectors and to discuss with them. I want to give you some examples to make it maybe more clear, because that's a very crucial point for the footwear manufacturing installations. So let's start with the easiest situation. You are an operator that is really producing a complete pair of shoes. So you use VOC adhesive, primers, and so on, and you do everything at one site in one installation. And if you exceed that 5 tons, then it's clear you make a complete pair of shoes in your installation. And so it's clear you can use and exhaust the complete total emission limit value, because you make the complete manufacture of shoes like it is described in this part 1 of the IED. Okay, other example. One operator produces a pair of shoes, and it's the same. You have solvents, and you do a lot of bonding. So at the final stage, you sell your complete pair of shoes. It's your final product. But some materials you buy already bonded, so that bonding or gluing processes are carried out by other operators, so not in your installation. So it's clear for that bonding steps where VOC emissions will take place at the pre-suppliers. So it's not possible that you, of course, can say, oh, I'm happy I can use now this 25 gram VOC emissions per pair of shoes. No, you can only use then the total emission limit value, but you must subtract then the emissions that took place by the pre-supplier. So the pre-supplier must inform you about his emissions. So if we look now to the supplier, so a supplier is producing bonded materials by using glues and so on for the shoe manufacturing. So now we can ask, what is the activity that is relevant for him? So for example, that can be the sole or insole preparation. So you understand, you have a supplier who is doing that part as a crude material. He sells it to the shoe manufacturer, and the shoe manufacturer then is bonding everything together and sells the final shoe. So here it's clear, if such a supplier is using, for example, adhesives and is doing a coating, then that activity that takes place at the supplier is an adhesive coating activity. So it's not the activity shoe manufacturing, but because here you have a surface like an insole or upper, and you glue some parts, and that part you sell to the footwear maker. So it's clear you have by the definition you're using adhesives, and I made it very simple here. You see you have a part A plus adhesive plus part B is part C. So it's exactly what you do, and part C you sell to the footwear manufacturer. So it's clear it is not an activity what you're doing under the footwear manufacturing, but it's an other VOC activity that is called adhesive coating. So yeah, so that I tried already to explain. So a fourth example, so a supplier is putting coat on a leather, and that is sold to a footwear manufacturer. So now, if the solvent consumption at the supplier is exceeding 10 tons per year, then it is a different activity, it's the coating of leather. There's another activity, and you see here the total emission limit values for the coating of leather. And yes, when you see that's the advantage, the total limit value, it is referred on gram VOC per square meter. And it's depending from the different solvent consumption that the operator has. So I think here is another interesting question, and I can give you only here my recommendation and or how I would decide. Here I would recommend always to discuss the different topics with your competent authority, because sometimes it's very hard to generalize the situation. It's better really to look on the specific situation, to see how to do an on-site visit and to see how it's working. So now here I want to give you my opinion on that following example. We have one operator that is producing soles by himself at the same site where the footwear manufacturing takes place. So I know one installation in Serbia already where it's doing this takes place. And here you're using polyurethane forms for to release the soles from the metal presses. You use a release, so-called release agent, and cleaning agents for the metal molds, and that contain VOC. Now the question is, for that production process where only the soles are made, really, I'm speaking now from the manufacturing of soles as a crude material. So my opinion would be like that, because the sole normally, only the poor sole you can buy normally by suppliers, and so that is something like a raw material. So in the case our operator has really that molds and is producing that soles by himself, from my opinion, that is a own activity metal coating, and so the VOC consumption from the cleaning and the release agent that must be considered under the VOC activity metal coating. That would be my opinion. There could be another opinion that would say if this is done in a footwear manufacturing installation, we have to consider all VOCs that will be emitted in such an installation. So, but I think that consideration would be not really fair, because only because the operator is producing the sole, so his own department for the sole production, and maybe he's selling the soles to other companies too, then we would add this to the manufacturing process for shoes, for the footwear. I think that is not fair compared to other manufacturers who are only manufacturing the soles in a specific installation for this. So that would be my opinion, but as I told you, this is something it is better you discuss with your local competent authority, probably with the inspectorate. When for example, you have what is called direct soling. So in very often you have now polyurethane or rubber process injection. It's called injection process. I will show you later, where you do already an assembling between the upper and the sole. In other words, I will show you on some pictures. You you save energy, you save glues if you have a direct combination between the sole and the upper. So we have so that can be done in one machine at the same time by the injection of polyol and isocyanate. If that is carried out in the installation, from my opinion, because it is an assembling process that we have to consider on the footwear manufacturing. So here in that case, I think we have to take into account the VOC quantities from the release and cleaning agents, because here we are really doing the whole footwear, complete pair of footwear. So that is an example, for example, where you only produce a sole, and that machine can, for example, stand in an installation for polyurethane or other things, and is only producing soles. So that was the reason I would consider, if only soles are produced, the VOC from the release agents, I would consider it as an own VOC activity, metal coating. Okay, so you see the shoot. It starts already with some complicated questions when we consider the activity. Another issue is the so-called IPPC directive, or the IED. Here, specific the Annex 1 and number 6.7, because if you exceed a certain capacity thresholds, like 200 tons per year and 150 kilograms per hour, if you would have such a large installation where you produce shoes and you use glues and so on, and with organic solvents, then maybe you will have a so-called IPPC installation, but generally that is not relevant for shoes. I don't know any installations where that is the case, but only to inform you, you have to check always if you have a surface treatment with organic substances, you have always to keep in mind this number 6.7 and the thresholds, and that you have to check. And important is that is the installed capacity. So it is not the normal consumption capacity, that is the real consumption per year, but here it is what theoretically an operator could maximum, or has already installed as a maximum. So it's like with the car, if your car has 450 PS, but here in Germany you can drive maybe only 30 kilometers per hour, then you will not use the 450 PS. So maybe you drive with maybe 90 or 60 PS, and but your car has the equipment to maybe to work on 450 PS. So it's the same here. For the IED, always a maximum capacities that is installed, even you don't use it, is relevant. But relevant for us here now are the 5 tons. If you look now to the requirements, and I want to show you maybe that short question or checklist. So if you start, always you have one operator, you have one site of one operator, and so you check what VOC activities the operator is doing. It is possible that in one site, several VOC activities can take place. You have seen already by producing the soles, I would say it would be in that way a metal coating installation, and then you would have as another activity the shoe manufacturing installation. So that you have to check, and then you have to check about the solvent consumption thresholds, because if the thresholds are not exceeded, here we have the 5 tons for both activities, then you are not under the scope of the activity of the chapter 5 ID. So finally, if both criteria are matching together, you are under the scope of the chapter 5 ID. What is now necessary? You have heard already about the registration and so on. Important is always that application of CMR. That means CMR are cancerogenic, mutagenic, and toxic for reproduction. And such compounds must be, of course, volatile organic solvents with the certain so-called age statements that you see here. So that's a way where you can recognize that materials. And if you have such, you should try to substitute them as soon as possible, in other words, in the shortest possible time. But sometimes it's not possible that you can substitute it. So you have to justify this to your competent authority. And if it's not possible, and the substitution order is always valid. So it is not that you decide only one time. So it is that requirements you have always keep in mind, and to check if there are materials available on the market where you can substitute such dangerous and hazardous materials. But if it's not possible, then you have to comply with the total emission overall CMR in the waste gas. And you have to work in a contained way, so not in an open way. So you must try to contain and your operations, and you have to extract the waste gas, and in the stack, then you have to comply with that emission limit values. The same, also similar, is with the volatile halogenated VOCs, and we may not forget the Serbian class 1 substances. If you have such VOC that fall under that classes, you have to comply in your stacks to 20 milligram per cubic meter if the mass flow is exceeded of 100 gram per hour. Only for remembering, because they're very common even in the shoe footwear manufacturing, or at least in the former times. Toluene, I would say it is now substituted in many products, and methylene chloride, that are all class 1 substances under the Serbian class 1 list. So you can recognize that very hazardous substances CMR here by these age statements. If you look to the safety data sheets, and you can see it by the pictogram. Some prominent, for example, substances are this N-methylpyrrolidone and formaldehyde. Yeah, I have here some other examples, but I think you will get that presentations for sure, and you can have them look by yourself more in detail. About this emission monitoring, you had heard already from my colleague Elena, and they are not so important for the, let me say, for the shoe manufacturing if you don't have any waste gas abatement, because that emission monitoring for the stack emissions are only relevant if you have an abatement, VOC abatement system. Yes, that is different if you have, for example, this such dangerous substances. Then, of course, you must determine the compounds in the stacks. And here it is necessary that you carry out that compliance check by that emission measurements at the stack. Now, coming more to detail, because we want to speak about the footwear manufacturing, what is relevant for you? Now, we have an installation that is producing footwear and is selling the pairs of shoes. Here, relevant is the total emission limit value. And that's a good thing, because the total emission limit value includes all emissions, fugitive emissions and stack emissions. So finally you have one value, and the way or the approach how you comply with the value is up to the operator. So you have different possibilities. So that's the reason I like that emission limit value very much, because it gives you a lot of flexibility. And here already, by the way, that total emission limit value is something like a reduction scheme. So for normally you don't need or it's not necessary to apply to a reduction scheme. A reduction scheme is a different tool or a different approach instead of to comply with stack emissions and fugitive emissions. But here it's not relevant because we have a total emission limit value where all ways how to comply are open to the operator. So I mentioned it already. You see that this is a solvent consumption threshold, and if you have identified that installation as a footwear manufacturer activity, we have to look, are the 5 tons of solvent consumption exceeded? Yes, then that installation must comply with 20 gram per pair. You see, that's very important, that footnote. That 25 gram now is referred on the complete footwear that are produced in that company. So now you can understand what I mentioned before. If parts are outsourced and done maybe by a sister installation or at a different site, it's clear that one who is doing that final manufacturing work, and if that person receives parts that are already glued, for example, from the upper or from the insole and so on, of course, that emissions that took place in a different installation, that must be subtracted here by from the total limit value here. I hope now that it's clear now why. Because that value is really referring on a complete footwear. Yes, so I just to point out again, the total emission limit value, it's really the whole emission from the food manufacturing process. That means the fugitive emissions and what comes out from the waste gases. And how can you verify it? Yes, the way for verification is the annual solvent mass balance. That is the way, and that I will show you how we do this. And here I can already yes tell you the best way, from my opinion, is to substitute the VOC materials. And now when you establish now in Serbia the VOC decree, and you as a footwear manufacturer or the inspectors who are working with the footwear manufacturing companies together, you think about what is now the best option for the compliance. I recommend you strongly to keep in mind, maybe if we have operators that are really willing to change from VOC to low VOC materials instead of using a waste gas abatement, because I think the waste gas abatement is only relevant for certain installations. The better way is to change to low VOC materials. So if you think about that, and there are materials that require sometimes where you need some prolongation, it is possible to give this time extension because then you can consider that as a specific reduction scheme. So I told already before, reduction scheme is not the right way. But what I'm speaking now is not the normal reduction scheme for coating installation. I'm speaking now on a what is called reduction scheme that is specific for an installation. Here, I think it is possible to justify if there is really the will of the operator to change to low VOC materials, but he needs some time to give him that time extension. But it's clear the operator must demonstrate his willingness, and he must demonstrate regularly his efforts to change to that low VOC materials. I will show you later from some very prominent companies that everybody of you know that sometimes it takes some time to change to low VOC materials. But for the shoe manufacturers, you will see in my last presentation today, there are already a lot of VOC, of low VOC materials available on the market. There are a lot of very famous Italian companies. Italian is a big player in the shoe manufacturing that know the VOC regulation very well. And that is the reason they changed their materials, and they are offering water-based lines and for some parts VOC. But finally, you have only to comply with this 25 gram VOC per pair of shoes. And there are already materials on the market. I only want to tell you to give you a solution when you start now this enforcement process and you think you want to change your production to low VOC materials, and you see that that needs some time. There would be a possibility to justify this, and this I wanted to show you. Okay, organic solvent, what is it? It's not so easy as it sounds. So the solvent definition is a very comprehensive definition. It is not only the dissolving of raw materials, it's a cleaning agent, dispersion medium. So a lot of materials are considered as solvent. And we are speaking about organic solvents. That means it must be organic substance. But now the crucial point is if they are volatile or not. And for that, we have volatility criteria, and that is 0.01 kilopascal as a vapor pressure at a temperature of 293 Kelvin. But very crucial, but not maybe here relevant for the shoe manufacturing. That is more relevant if you use higher temperatures in a dryer. That vapor criteria is to apply at the particular conditions of use. In other words, if you have a dryer and you have high temperatures like 150 degrees Celsius, then the vapor pressure, of course, will be higher of such an organic solvent. And so you have to consider if at that drying temperatures, the volatility criteria is complied or not. So, but for the shoe manufacturing, I think that this issue is not relevant, because we have only normally working processes at our room temperatures, and maybe in the heating we have some some heating steps, but I think the temperatures are not so high that that it does really play an important role. Yes, what are adhesives? There are different definitions, but it's clear that are materials where we adhere separate parts together to a product. And yes, this I showed you already. I just want to mention it. You can calculate the vapor pressure, of course, by using, for example, that vapor pressure curves, for example, the Antoine constant. There are different tools in the internet available where you can, yes, calculate the vapor pressure of different materials. So, for example, for ethyl acetate, that's very common solvent. For adhesives, you can calculate here the vapor pressure. But normally, I think for the shoe manufacturing, it is not relevant. Yes, if we look now to the footwear manufacturing, we have a lot of parts and they are finally assembled to our shoes. And so what, let me say, bonding processes we have. We have bonding processes by glues or adhesives. So if I say something glues, it's the same like adhesive here. Then we have mechanical fixing steps like stitching. And we have steps where glue and stitching are applied together. So we have different working steps, for example, the upper preparation. And here adhesives and or stitching is applied. And here you see always, so let me say what is very common. For example, for lining leather and leather, you see solvent-based adhesives, latex adhesives, and leather woven, leather foam. So different types of adhesives will be applied. So we have finally, let me say, 3 types. We have what is very good, dispersion in water, what we would say water-based adhesives. But please take care. Water-based does not mean it is zero VOC. So that means zero volatile organic compounds. Water-based means maybe the VOC content is very small, but if you do later your solvent mass balance, it is for sure that you have to check if maybe there are some parts of VOC even in water-based adhesives. So we have hot melt. For hot melt, I would say they have no VOC. So hot melt is a really environment-friendly technique. You know, hot melt, you have, you see here that that adhesives that is solid, and by the application of heat, the solid will be liquid, and then you can apply, by example, by a pistol on your materials. Yes, and then we have I would say the classic adhesives that are based on organic solvents, and this you will smell it, that have typical characteristic smells. Very often polyurethane is solvent as adhesives are used, or neoprene adhesives, and the application is done very often manually by, for example, paint brushes, or can be automatically by different machines or guns. Yes, so what are the contents of that solvent-based adhesives? So generally, if we speak about a classic solvent-based adhesive, it has a content about 70 to 80%, only to give you a number. So you see, if it's a solvent-based adhesive, then you have to look very careful on it. Typical materials in polyurethane adhesives are acetone, butanone, and especially MEK. That means methyl ethyl ketone. That's very prominent, and ethyl acetates that are very prominent materials. And in isoprene adhesives, you have hexane, and very often in a high quantity cyclohexane, and ketones and ethyl acetate. So where can we expect now solvents or solvent containing adhesives? You see, we have here different departments. We have the shoe upper department where the upper is managed. We have here the fitting department and the stitching department. And then it comes to the lasting department. Later you will see what it is. And before you have the sole preparation. And sole plus the lasting comes together, and that is then called the sole assembly. Finally, we have some finish operation, because people like if the shoe has a nice shine, and of course you have maybe some rests from the glue, so somebody has to take away that rest of the glues. So you have what is called finish, and here you see always the different type of glues that are possible for the different steps. So here, especially in that steps, we will find solvent containing materials, and in the finish too, but that are maybe the most prominent steps, but I will show you later on. First, for visualization, what is the gluing process? We put parts together, and of course this adhesion later is very important, because nobody would like if the shoe, the sole and the upper will be separated after you have used it half a year. I think you will be very sad if your shoe then is doing a separation between the sole and the upper. So especially, for example, if you have heavy boots like safety boots or for the mountain, it will be crucial that here that adhesion must be very, very excellent. And now maybe you are already asking yourself, I told you before, you have 25 grams per pair of shoes. Now maybe you are asking me, is there a differentiation between different shoe sizes? And I must tell you, no. But it is easy to understand. If somebody is doing only small shoes, of course the area where you have to use here glues is much smaller. If you're producing maybe for large people large shoe sizes, like maybe 44, and that's maybe not large, but maybe some 46 and so on, the glue consumption will rise up, and of course the solvent consumption will rise up too. Here, for example, for the man size, you see the different gluing areas. So it's clear if you have a slipper, the area that we have to glue is much less if you compare then to a mountain boot or a safety boot. Yes, or sandals have less gluing areas. So yeah, here I look a little bit on the time. Here you find later the properties different glues and materials must have that are relevant for the shoe manufacture. And the most important relevant point is, let me say, that part where the preparation of the sole and that assembly of the sole and the upper, that are the most relevant parts. And here we have, let me say, the highest VOC emissions if VOC containing materials are applied. So the next step is, I would like to make you a little bit familiar with, or those who are not so familiar with the different manufacturing steps and where the emissions will result. So, for example, here you see something. Here's where parts here are fixed together, and by that machine, the parts are glued here together. And yes, and that's the way the shoe is manufactured. So you see, such a shoe exists from many parts, depending from the different type of shoe. Here, that is called the upper, and the other is the sole. I think that's clear. And the footwear industry here in Europe, it is a sector, I would say, more for smaller and medium installations. And here you can see many companies here have an average about 10 to 15 employees. But of course, that is it's depending on the situation. So just to give you a number, you see, okay, there are some simple shoes, but some shoes maybe have 150 parts or more until you have this final product. Here, I admit that it's a little bit maybe not very representative, but I think so much it didn't change. That's the situation in Germany. You see, some ratio are here the street shoes. We have a lot of sandals. Then we have some spatial shoes like safety shoes or for the military or other spatial applications, mountain shoes, and yes, and sport shoes. That is so the sector here in Germany. I tried to find out how's the situation in Serbia, and I found here interesting list. So that maybe are the companies who are relevant for the shoe manufacturing in Serbia. But I think when I tried to research the different companies, that only a few maybe are really yes, covered by the VOC decree, because probably the solvent thresholds of 5 tons per year will not be exceeded. Many or some of that companies I found in the internet, and some are really maybe family companies where 4 or 5 people are working, and they do spatial shoes. I found one shoemaker in Belgrade that is probably a family operated one. So next time, if I go to Belgrade, I probably will visit this man, because I found I think he makes wonderful shoes. But of course, it will depend what the cost. It can be very expensive for me. So there are some nice shoemakers in Serbia. And here again, because really that is to understand, it's really important. We have a lot of different small parts that are assembled together, that we get here the shoe. You see, even for the soling, if you do a sole, you have maybe different parts that you must fix together, and that you are doing by glues. For especially for the shoemakers now under us today, it could be interesting. There is a very nice project that was done here and supported by the EU. Here you can, it's called under integrating companies in a sustainable apprehensive system. Here, that was a project where really companies were trained to produce in a more sustainable way. There are a lot of materials in the internet, very useful, I can tell you. That was the reason I wanted to put this for you in the presentation. Yes. So again, here, when we start, we have here a lot of course, cutting processes, sewing processes, stitching, and of course, as I told you already, glues here in that part are used. Then in the lasting process, we have glues and bondings, and to the upper to sole assemble, we have to apply glues too. So in the finishing, you have polishing and mechanical processes like brushing. But of course, for cleaning operations or coloring or impregnation, it's very often VOC containing materials. Yes, here in the upper department, we have about maybe 10% of the adhesives that are used. The other adhesives in the upper department, because maybe there is not, you can use different adhesives maybe that are not so strong as others. And so here it is very common not to use solvent-based materials. Yes, now the lasting department, just for those who are not clear what a last is, you see that is the last, it's the form. This form is responsible that on the form and the size of the shoe. And here the upper is now what's called by the shoemakers, that is pulled over and stuck down to or tacked to the insole. So in easy words, the insole and the shoe upper are here joined together. And to do this, you need this part, this last, and that is depending from a different size and models. So that last is finally only a tool to make this assemble of the insole and the shoe upper. Yes, and in that lasting department, we can be maybe happy because here very common are so-called hot melt adhesives. As I told you before, that hot melt adhesives, they cause no VOC emissions, and very often you will find here dispersions based on water. So here in that lasting department, we will meet only small quantities of solvent-based adhesives. So here normally are not large quantities of VOCs. So you see, only to give you an impression, that is a machine to do this. Yes, this lasting. So you see this upper is molded onto the last and is then fixed by a glue, and that is done direct in the machine. So that are typical stands for that lasting department. Yes, then we have preparation department of the sole. Here, a lot of different glues and VOC containing materials are used for the pre-treatment of soles. It's important to achieve a strong adhesion to the adhesive by the sole, and to do this, very often you need so-called halogenizers. So that means you have to take care. You set a special materials, and here it's good if you look on the safety data sheet, because they can be, I would say, hazardous in some cases. depending how modern or what materials are applied. But here it's really worthwhile to have a deep look. What materials here are used, and yes, in that pre-treatment department, you see, so that must you have different type of soles, of materials, polyurethane, PVC, for example, rubber, and so on. So different materials. And depending from the type of material, you use different steps for this pre-treatment. So anyway, normally you need always a primer for the most plastic materials. And in some cases, you need this halogenating step. Yeah, and that can be then VOC relevant. So in the sole assembly department, we connect the insole, or the sole is connected to the insole and this shoe upper. So that is, I would say, the highest, or the process with the highest VOC emissions. And here, very often solvent-based adhesives are used based on neoprene or polyurethane. Meanwhile, I think many installations, depending on the type of shoes, of course, the so-called injection molding technique is used. What does it mean? That is the bonding of the upper part and the sole, where you produce the sole, I would say, in the same moment where you have this assembly. It's a injection process. So I think that is a very, very smart and very modern process. Later, when we speak about the BAT, I have some pictures for you. So yes, so that is an overview on the direct, let me say, possibilities to assemble the shoe bottom with lasted uppers. So that is one of the most important processes. Yes, here are some examples where so-called heat-activated adhesive is applied. What does it mean? You put adhesive on, for example, here on the materials. That adhesive then is drying, and but for the gluing process, let me say, the assembling, also where you glue two parts together, you need what is called heat activation. That means you must put heat on, for example, here on that material, and on the other side that you want to fix together. So by the heat, the adhesives that you have put before on the material will be activated, and then you can just press it together. So that's what is called heat activated adhesives. So it's very common in the shoe manufacturing process, and very often that materials is already pre-impregnated. That means already with such a heat activating layer. So the shoe manufacturer just must put the heat on it and can glue it together. So the VOC emissions you have are normally only if you put the layer on the adhesive on in this preparation step on the part. Here's an example just to show you why. Two things I want to show you. First, many things are done manually. There are some automatic lines, sure, but I would say many working steps in a shoe fabric are still done by manual operations. And what does it mean for the emissions? That means you don't have normally something like a continuous emission on the same level, because you take the shoe away, you take the shoe, you like here, you have a brush, you put paint adhesive on it. So it is always, you have something like a peak of emissions. Of course, if all stands or all operation places are working, but you have something like a very yes, continuous emission situation. But if you look more in detail, you will see always peaks. So it is not like a line. That's one thing I want to tell you. And you see, the emissions are resulting always from that application of the clues. And for sure, if you improve your situation by using low VOC materials, you will improve the situation of the workers too. Because you see, I cut it off the face of the woman here, but when you do this application of the glue here, you will get, of course, the VOC, and then it's important that you extract the VOC emissions from the working places. So then you have this adhesive drying, the heat activation in that case, and here you do this pressing, you see, from the upper end to the sole, because first you have done it in that heater, so the adhesive was activated, and then you press it together, and yeah, so you get the shoe. I showed you already this. So in the finishing, I spoke already. But in the finishing, I want to tell you, we have maybe about 20% it can be possible with VOC emissions, because here a lot of materials containing VOC. Okay. I look a little bit on the time, so you will get everything. Here I want to show you a representative, yes, a glue. It is here from that company. I told you the Italian are very famous with footwear manufacturing. I think Italy is footwear manufacturer #1 here in Europe. And they have many companies who are very famous for of course, for the materials and for the components and for the glues and adhesives. So that's the reason I've chosen here one supplier of adhesives, very famous one, I think. And you see that is a solvent-based adhesive. And here you can see esters, ketones, as I have shown you before. And you see that has 22% about solids, and you can imagine about then 78 is VOC. So a typical VOC containing adhesive, as I told you, classic is 70 to about 80% VOC. Now, what are the emission sources? Here, that picture gives me a chance to show that in a good way it is or the best technique to extract the VOC emissions directly from here, for example, heat activating or dryers, so that the VOC are not getting into the room, but they are collected and extracted here to our Batman unit. So that is an example for my Batman unit. Yeah, just to give you an overview on fashion shoes, if we have 100% input, you see by here that part with heel, we have about 14% relevance. But here I made a bomb. the sole assembly, I repeat now what I told you before. In that part, we have here the highest emissions from the fashion shoes. And for heavy boots, the sole preparation, I told you already, because for the heavy boots, the adhesion must be very, very good. That means you must prepare the sole that later you have a good fixation to the upper. That's the reason you have here VOC materials and this halogenation process. Yes, and you see the upper preparation, and here's the sole preparation. Here I made two bombs for you to show that are the highest VOC emissions from the production process. Yes, for children, situation is different. It's clear you have less area where you have to put adhesive on it, and so it's clear you have less VOC compared to the heavy boots. So typical ranges are 20 to 60 gram in the former time, when 1999 the solvents-based emission directive was placed into force. Yes, I can tell you generally no exhaust gas abatement technique is applied in Germany, but there are exceptions. For example, heavy boots and footwear, mountain boots, such installations apply a waste gas abatement technique, because they still need the solvent-based glues, especially for the sole preparation and for the sole assembly with the upper. Yes. Here is a study. I just only want to show you the result. That study that was taken in many years, not many years before the solvent directive was placed on the market. There was a calculation to demonstrate that even for a simple shoe, about 117 gram of solvent, mostly this methyl ketone, will evaporate. You see, the VOC manufacturing is VOC relevant, or was a VOC relevant activity. Yes, to show you some examples, Adidas in 2003, you can see the situation. They didn't comply with the limit values. The limit value is 25 gram, and that was the situation here. In Germany, the directive, the solvent directive, was implemented in 2001, and the companies had some transition times for existing installations for compliance. But I just want to see that the reduction took time, and you see in the next sheet. Where is it? Oh, normally it's missing here. But if you look now to Adidas, you will see Adidas is now, of course, complying and has a very low consumption. Probably it's in the final presentation under BITs. But that I only want to tell you that the way how to comply with the solvent directive for the footwear manufacturer was to change to low VOC materials. That's the best way. Yes, there are other studies that showed that footwear manufacturing emits hazardous compounds, but that is, I think, changed. Here is a just to see what materials are relevant, and you can see by this chromatogram the most relevant solvents are acetone, methyl ethyl ketone, and ethyl acetate. So nowadays the very hazardous substances are eliminated by the, I would say, the manufacturers of footwear adhesives here in Europe. I think they realized the problem and they tackled the problem, and so they substituted generally the hazardous materials. Here is a study from 1999 in Portugal, where an institute did measurements, especially for occupational health, and in the surrounding of the installation. And there were a lot of shoe manufacturers were involved, but you can see here, you see the most prominent solvents. For example, I hope that dichloromethan, I hope that methylene chloride I will not find anymore in that quantities today, but that was 1999. But you see, it matches exactly what I told you before. And here are the values. You can see there were really high concentrations measured. Yes, and directly here in the working rooms where the food manufacturing took place. So for the occupational health, the use of the VOC containing glues are not for very healthy too. Here, that is from environmental statement when Adidas a very a player who likes to work very sustainable, and so they did consideration what are the environmental impacts from the shoe manufacturing process, and they did it for their environmental statement. They report every year, and you see noise, dust plays a role, of course, but of course solvents is or the use of solvent emission are very important. So interesting, Timberland, I think everybody knows too. If you look here in the environmental report, they were in 2015, they didn't comply here. And I was wondering, they have 42. So if you remember, 25 is the limit value, so they exceed the limit. And here is then something explained in the quarterly report. And the problem is that is a result of probably several installations. And there are still some installations that are not complying, but this company is working to comply. But if I look 2019, 2020, so they made a progress, and maybe in the next years, maybe they can comply. But you see, even a big company like Timberland has here some problems for compliance. To show you just the situation, because we start now with the solvent mass balance, and you will hear some terms. So to explain you the different terms for the emissions. So if you have a waste gas abatement and you have you extract your VOC waste gases and you put it to a waste gas abatement, that what gets out as a clean gas that we call O11. It is just a classification. It means captured clean gas by our VOC waste gas abatement, not by a filter. Filter is for dust, but not for VOC. So then we have a situation where you have like here a working place, and the air is extracted and discharged outside by a stack, or you have a machine that is, that, as I showed you before in the picture, that is connected to extraction tube, and that is then discharged to the atmosphere. So we call this captured not cleaned waste gases, or 1.2. Yes, here we have what is very common. We have a room ventilation system, and those VOCs that are coming from the operation places here will be collected and discharged to the atmosphere. So that is uncaptured, and we call this fugitive. It's a part of the fugitive emissions. And here, for example, we have emissions from the doors, from windows, openings, so emissions that you don't capture compared to that situation here. Like the name says, the idea is simple. So what you put in as a VOC containing solvent, that is called I1 or I2, if you do a recycling and you put in the same year the recycled solvent again to your activity, here in that case footwear manufacturing, that quantities of course must be equal to all of the output flows yes, from the installation. So the solvent mass solvent mass balance is a part of the solvent management plan, and the idea is to verify the compliance. And in our case, for the footwear manufacturing, the total emission limit value is relevant. So that's the idea. We need the solvent mass balance. It's like a measurement report. If you would measure at the stack, that is necessary for the check if we comply with the total emission limit values, because as I told you, the total emission value covers all emission from the footwear manufacturing process. That means all working steps, all VOC emissions from this manufacturing. So reduction scheme is not relevant, as I told you, and responsible for this solvent management plan is the operator. So the solvent management mass balance is part of that environmental management tool. How is the best way to establish such a mass balance? The best is to organize a team, and you need a responsible person, and then you must plan. We want to identify all VOC activities, and we want to establish such a mass balance. That means we need all input and output flows and must determine their quantities. That means you must do a lot of work, because even when you start, it is new, and you have to cooperate maybe with a lot of people who are responsible for the purchase of the materials, and you probably need something like a database. And then if you have all data, you must check and analyze them, how reliable they are. Maybe they are misunderstanding. For example, if somebody is using a paint for painting the walls of the working places, I mean, that is not that falls under the VOC manufacturing activity. Yes, only the VOC that really are relevant for the manufacturing are important, and of course from the cleaning of the equipment that you are using for the manufacturing, but not, for example, if you do some renovation work and use some VOC containing paint, if you use is for some walls the fabric hall. Yes, then if you have all data and you have analyzed and checked everything, you probably have to get in contact with suppliers. I can tell you in my preparation of the presentation, I was in a lucky position that I had some safety data sheets from some operators here, but it is not so easy to get the safety data sheet. So that is something I would call it work. You must contact your supplier, and that supplier normally is now adapted according to the European legislation, that he knows what you need. I mean, he knows that you need the VOC content from your adhesives and cleaners and finishing materials and so on. So you can elaborate now a solvent mass balance. And maybe if you see everything is fine and you comply with the 25 grams, you can be happy and can say wonderful. But during this check, I want to tell you, please keep in mind, if you get materials from your sister installation, or you have outsourced some gluing steps that are relevant, then you must get the emissions from that supplier, because you cannot take into account the full 25 grams, because in your installation you don't do this gluing processes. So you have 25 gram, and then you have to subtract maybe 5 gram, because that 5 gram your pre-supplier emit during his gluing steps for the preparation of the materials for you. Yes, so here you see all the flows. It looks rather complicated, but you will see for the shoe manufacturing, it is not complicated. Important are that what you buy and what you have put in the 12 months. Generally, you will not have, as a for footwear manufacturing, generally it's not so common to use a distillation unit. So normally you will not have recovered and reused solvent that you use in your installation. That is, I would have some serious doubt if you would have. So I would say generally that is zero. So normally you don't have a internal recycling. Yes, and the same, what you see yellow are what is called fugitive emissions. So of course you have, for example, in your shoe that is finished, you will have maybe some VOC still, but that quantities will be not large. So and they are fugitives. O4, that means all what comes out by uncaptured emissions. We have untreated, that means not cleaned exhaust gases coming out from stacks that we consider normally as fugitive emissions, but here it will not play any role. It is not so relevant, this differentiation, because we have this total emission limit value. So the total emission limit value covers all emissions as that you see labeled with an O. O2 in wastewater, normally you would not have, only if you have a spray stand where you operate with a water film. Some oil installation could have, but and then you have, of course, VOC in the wastewater, but normally, generally for that spray stands or working stands, dry separating materials for the adhesive particles are used and applied, and not a water film. So if you would have waste gas abatement. That would be maybe a thermal oxidizer. That means you have a waste gas abatement that is destroying the materials. Then this O5 is very important for you too, but only if the VOC are destroyed. Important maybe can be this O6. You see O6, it's a collected waste in a closed container. That's the reason it's not yellow, because it is not it is not fugitive. I mean, it is collected, so it is contained. That's the reason all the VOC from cleaners and from cleaning racks and so on, they are collected and covered in a special waste box, and so it is waste, and that VOC that is in that waste is discharged to a specialized waste company, because it's a hazardous waste, and that company can give you the values, how much VOC is inside. That value is important, as you will see, because we can subtract it. Yes, important is the so-called solvent consumption. Why? Now a small test for you. Why it is was it important, or is it important number? Because the solvent consumption gives you the threshold. I mean, if you're below that 5 tons, you can be happy. You can have a footwear manufacturer, as you probably have a lot here in Serbia, but that are probably family operated companies who will not exceed the 5 tons, because they do this footwear manufacturing by their hands and with less machines. So it is not a automatized system. So that solvent consumption is absolutely crucial to know, because that will decide if you fall under the VOC decree or not. So what is the solvent consumption? It is here mathematically that what you have bought minus 0.8. What is 0.8? 0.8 is something that you have recovered in your installation. Like if you apply a distillery, a distillation unit, and you distill you get back the VOC, the solvent, and you store the solvent, or you in that time of a year, or you put this recovered material to another VOC activity. But for the shoe manufacturing, 0.8 will play no role. I would say you can forget this, because you will have no recovery of solvents. You don't operate a distillery, and so generally this is 0. Yeah, so the solvent consumption you have to determine for the whole year, and please don't forget, solvent is a very comprehensive term. So cleaning agents and so on, we have to consider too. So not only pure solvents here are under the term solvent. So that is not so important. Yes, so I told you already. So the best to determine the solvent consumption is to use something like a table, like an Excel sheet, as you heard from Elena, where you have to list all, or check. First you have to check, or you must familiarize this team that will establish this solvent mass balance. They must learn where are or what materials are used in the different production processes. That's the first step. Then you have to list all the materials, and you have to analyze if they contain VOC solvents. And then you write this in such a table, and you need then the consumption. and that means the input. If it's based data on the volume, it's no problem. You can calculate it by the density, and so finally you need the mass per year. Then if you need if you have the information from the supplier on the solvent percentage, how much is included, then you can calculate the VOC for each material. I want to see, you see here an example. I didn't write now the name, what material it was, but for example, for all materials, you have to analyze it. So that list for a large installation can be very large. And it's not possible to work with, how can I say, averages, or for example, you say, yes, or a group of materials. You say, I have cleaners, so I assume my consumption of all cleaners is, I don't know, 1 ton, and I assume the solvent content is maybe, I don't know, a certain value. For cleaners is not a good example. We have to say maybe adhesives, because cleaners generally have 100% or very often 100% than VOC. But if you speak about adhesives and you say, oh, we have, I take for me the best value, maybe 20%. So that's not what you can do. You need really to list every material. You have to analyze and to do this assessment, and you need the calculation about the quantities. So for the footwear manufacturers, maybe how can this maybe look like? For example, you can make it more systematic. You do it by the different departments, because that are the working units in a shoe fabric. So you have the upper department, you have a lasting department, sole preparation, I told you, the sole assembly. So that are maybe the most prominent VOC containing materials. And here you have now to list every different, yes, every different supplier or material here in that list. So you start with your inventory 1st January, what you buy and what then the end you have in your storage. So you can apply, you know, you need the mass content. You have probably to ask, in most cases, to the supplier, and you can calculate then the quantity. And this input is what you have at the beginning, plus what you have bought, minus at the end. Yeah, so you can calculate this input. My recipe for you is, as I told you, you have first to make sure that you have a register of all materials. And I can tell you, really, it is necessary that you visit and you have to cooperate with such people who do the work, because otherwise maybe you get wrong information. So just to see what materials are applied for the upper, what materials are applied for the lasting, and so on. So you must really systematically analyze all the materials that are applied, and then you check the VOC content, and then you can elaborate this list. But 08, as I told you, I don't think footwear manufacturers operate. I don't know any distillation unit. Here you have set safety data sheets that are very important. Why? Because you have additionally not only look to the VOC content, you have to look on the hazard statements. So if you would see here a hazardous statement for a CMR substance, that would cause us problems because such material, as you heard, must be substituted in shortest possible time. But so that's the way, for example, that is a halogen primer substance. And then we can look what's the reason. So most here is ethyl acetate. And it contains a little bit of such material, but you see, you must remember now, if you have this H statements for the halogenetic ones, and if it doesn't have, it's no problem, but if this H statement for the halogenated one substances here is complied or is given, then you must keep in mind that for the stack emissions, they may not exceed 20 milligram per cubic meter. So important for us now here for the solvent mass balance is this VOC content, and so you see it's almost 100%. Here is a safety data sheet from that Pression fulcarobrine. That is a material were are activated then by pressure. Yes, and here you see so the typical materials and the VOC content. You see it's 80%. That's the reason I made here a bomb. Then, of course, you must always look on the vapor pressure, because why? Remember, because the vapor pressure is the criteria when we consider an organic solvent as VOC or as a solvent under the VOC decree. It was a 0.1 kilopascal per 20 degrees Celsius. Yeah, so here in my presentation, you see then more explanations how to determine the different important inputs and outputs. I will skip this a little bit, because why? For the shoe manufacturing, it's not so complicated. So, for example, yes, if you have a waste gas abatement, then it's important, of course, to do all these determinations. But give me a chance to jump to the compliance check. The total emission. How are they calculated? So we have no limit value for fugitive emissions. So that is not relevant for us now. For us, relevant is only here that total emission. So for remembering, total emission means all emissions of VOC that gets out by fugitive way or in a captured way. So if we check now it by calculation, we see they are the fugitives plus the emissions by stacks. Now, how can we calculate it? We use the indirect method. Indirect method, why? What does it mean? We say all what we put in, that's the I1, you remember, and remains after we subtracted that contained outputs, that must be the emissions of the installation when we see it as fugitive. But here we have the spatial situation that O1 from the stack will be eliminated, because you see O1, that is the captured emission here, but that part here, like here, if we make here a bracket, that is the calculation method for the fugitive emissions. So it is here eliminating O1. So finally, for our formula, we have only the input minus O5. O5 is if you would operate a waste gas abatement, and that is based on destruction of VOC, like a thermal oxidizer. Then you would have O5, and you can subtract it from the input. O6 is the contained VOC waste, so it's important to know what's the VOC mass content in the waste. You may not use the whole waste as and subtract it. Only the VOC containing or the VOC quantity of the waste you can subtract. O7 is not applicable because we have no, we don't sell solvents in products like paint. And O8 is because we don't have normally recovery of VOC solvents, so it is 0. So very easily, again, if we use the indirect method, and that's the best option, we start always what we put in, and we subtract what is fugitive, or no, what is not fugitive, and by that may calculate, and we have to add the captured emission to it. So at the end, this O1 and O1 here will be eliminated, and we get this simple calculations. So there could be another option for calculation. If you use the direct method, what does it mean? Direct method means you add all of the fugitive outputs and the stack emissions together. So that would mean you must determine all the fugitive emissions. That takes a lot of time, and additionally, you will have a lot of problems, and the accuracy is not, the precision is not very good and enough to check the compliance. That is my experience. So the direct method is not a method that I recommend to you. It is only applicable for very special cases like clean rooms. So here in that table, you see what is relevant. I1, and then the rest you can forget. If you have a waste gas abatement based on destruction, then O5 is relevant, O6 is relevant, but it's not a very high quantity. But it can be important in case the compliance, you are at the limit value, in the range of the limit value. O6 can be very important too. The other quantities I told you are not so important. So here I try to visualize the important things for the footwear. I would say only I1 and O6 are relevant for the footwear manufacturing. So the formula is very simple, because the other you can forget. Now, what we have to do, we know the limit value is 25 gram. Oh, I see, here's a mistake. It's not C, total carbon, it must be here VOC. So that I have to correct. So you will get the corrected version. That is it was a additional mistake by me. So it may not be, it's not referred on total carbon. It is referred on VOC, as that means on the molecules, and not on the total carbon. Then we must determine this total emissions that we do by the solvent mass balance. So finally, we have only I1 minus O6. So when we know what is the VOC content and what were the quantities of the materials that we have used for the shoe manufacturing, we can calculate this I1. And if we know the quantities of VOC in our VOC waste, then we can calculate the total emissions. Then we need to know how many pairs of shoes we have produced, and then we divide this total emission here by the total produced pair of shoes in the time period. Yes, and then we can hope if we comply, if our determined total emission per complete pair of shoes is equal or less than the limit values. Yes. Important, as you can see, is I1, because I1 is a large number. And here you must really be very careful that you get in precise data from your supplier. And finally, you must elaborate a reliable mass balance. So it is very worthwhile if the operator do something like assessment on the uncertainty to explain how reliable is mass balance. Again, because the limit value is referred on a complete pair of shoes. So if parts are made by a sister installation or others, that must be taken into account in the solvent limit value. So you must, yes, you cannot use this 25 gram as a whole. So the best way to comply with this complete emission limit value is to change to water-based glues, use high solid glues, use water-based cleaners, you see, just to work on primary measures. That would be the best. Or if it's possible for you to use that direct upper and sole bonding system by injection molding. Here, even there, you can save VOC emissions by using water-based release agents. Some examples. For example, we have maybe 600 yes, we have 600 of 7.5 liters of adhesives are consumed. We have 3 types of adhesives and 200 cans of that type is consumed. So finally, we have about 10,500 liters. And we calculate this now by the density, and we get about 8,000 kilograms of that adhesive that is used in the shoe fabric. That contains primers, cleaners, everything. So that is already aggregated value. The value is of VOC is 70%. So you see, we just reach the threshold of 5 tons. That is what you can learn here. That are already our VOC emissions, because we have no vice gas abatement. So, and we have no So that's exactly what we put in will be emitted to the atmosphere. So here 14,000 pairs of shoes are produced, and what you can see for that installation, it would have 420 gram VOC for a complete pair of shoes. So no compliance is given, but that value is really very high. So that example is not a good example. I mean, it's a good example to show you that the operator has to do something, but what could be the solution? I must admit that is an installation that is, I would say, not a big installation. It is more not very small, but like the shoemaker in Belgrade I have in mind, but it is an installation that is not so big too. What they can do, the solution is, if they reduce a little bit and change to water-based materials, they can reduce the VOC consumption, and if they are lower or less than 5 tons per year, the VOC decree for them is not relevant, because the threshold, they are below the threshold. That's the point. So you see, one strategy can be to lower some parts of VOC containing materials just to become or to get below the VOC threshold. Of course, it must be reliable. I mean, it makes no sense in one year you are over the threshold, other year you are below. That is not a good situation for everybody. You should really reduce the VOC in the materials that you are always below the threshold. That could be a solution for such an installation. Because here you see they have 420 grams. It's really hard for them. They would need to change a lot of materials to comply with 25 grams. Another example, 70-20 tons of cleaners and thinners you will find, and you look to the safety data sheet and you see it's always 100%. Then they use glues with 53%, and you can calculate about 12 tons VOC. Yes, then no abatement, nothing exists. So you can do the same. You can calculate the total VOC consumption. That is already the emissions. And if they have here 1 million pair of shoes, they will have here 38 gram VOC per pair of shoes. What does it mean? No compliance is given. So here it's the same what I showed you by Timberland. That's a situation where you can try to now to analyze the different application steps for the glues and to try to do optimization. So what could be, let me say, to solve the problems with the VOC decree for compliance with the total emission limit value? So the best would be to prevent the VOC emissions. That's the reason I made here the ground for it as for the King's Way. If you can reduce the VOCs and buy materials with low or VOC adhesives or cleaners, or what would be good to prevent gluing steps. So if it's not possible, what can you do? Then you must capture the concentrated waste gas streams from the working operation stands. And here you have then to apply a waste gas abatement system. As I told you, that's a secondary measure, but some shoe fabrics, but that are spacious shoe fabrics, they have to apply our waste gas abatement system because they don't want to change to VOC, to low VOC materials. And if you have that concept, you have probably no other chance. So the best is to start with number one, try to prevent the VOC emissions, and then if not, you must try to concentrate the waste gas streams and extract the waste gas streams at the origin where the result, and then you must purify them by the application of a VOC abatement system. So here, so that is here something again a little bit summarized. First, it would be good always if you have VOCs at working stations that you extract that working station alone because of the occupational health for your workers. And if it's possible, it would be smart to automatize the processes, for example, by using application robots. There are very nice working stands that use robots for the spray application of glues. Meanwhile, in shoe manufacturing installations. And if you use spray application, manual spray application, or automatic, doesn't matter, then try to use application systems with less overspray. Yes, the other thing is, I told you already, it's like a credo in the church. Try to analyze the system and use and change to low VOC materials. Another thing is the good housekeeping and other preventative measures to reduce the VOCs, like it starts by the storage of the adhesives, by the mixing of adhesives. You can do it open or you can do it in a closed way. So there are mixing apparatus that are working closed with a cover. So it is better you do like that. Or you can work in different way. You can have a central adhesive storage, and from there a container with the adhesives, and from there you have fixed lines to the different working stations where the worker are gluing the parts together. So it is not that the VOC containers then are open-handled. No, it is really, there are fixed lines to each of the operation stations. You can cover the floor with a spatial film, so the people can see if they didn't take care. You can see then the glues, but so the workers will be educated to work more in a clean way, because nobody likes to walk on a floor with adhesive where you can feel the glue. The good thing is after a certain time you can exchange that cover from the floor and replace it by a new film. Yeah, that can help to reduce the fugitive emissions too, but of course it's only in a small part. The regularly cleaning of the working places is very crucial. There are cleaning apparatus that are closed for the spray guns. And for example, if cleaning wipes and other solvent waste, yes, it's better to take this in a closed special container. So there are a lot of operation options to improve, let me say, the good housekeeping and the operation at all, and it will save you money. That's important to understand, because the glues are expensive, and if you save glues, it's better for your production process, and it saves money. Here's an example I want to show you. I have to hurry a little bit. I make it very short. So here are 3 different options to improve something. And the one is you do nothing, and then you can calculate here by your solvent mass balance. You can calculate the different effects of doing nothing, or do some exchanges to low VOC materials. And you can see by the result what will be the outcome. And then you can calculate the emission limit values. And you see here for the first scenario, doing nothing, the values are exceeded, and then you can see the improvements. And so for the improvement number 1, with the exchange to water-based materials, you have then a big reduction, but you will not match maybe with 25 grams. And so you can continue with the next scenario, and you can find out what must you do to be in compliance with the total emission limit value. And the good thing is this total emission limit value gives you a lot of flexibility. So you can improve the good housekeeping, you can improve the techniques, and so on. Here is a third step, the application of end of pipe technology. You need here the efficiency of this waste gas abatement. So I made here an example how that could work. So if you know the efficiency, here it's not so much. You can calculate the effect, and you can then see what would be the best solution. But it's clear, if the destruction efficiency of the waste gas abatement is very high, of course the destroyed quantity O5 will be large too. And if you remember from the solvent mass balance, if you go back to the formula, we don't have it here now, but if you go back to that formula, we can subtract O5, and that is very good. So yes, I will make it short now. There are different projects, for example, green shoes here in Europe, with the aim to reduce the total environmental impact from the footwear manufacturing industry. That could be interesting for those under us that are doing footwear manufacturing. I recommend to have a look on this. There are in Germany, but it's written in English, environmental standards in the shoe sector, but not only for shoe, but for textile. There are some best available techniques here for the shoe manufacturing, and you see these environment friendly techniques are very similar what I have already told to you. There is something in a checklist you can download, and there are some examples, for example, from Hanwag, to reduce the VOC emissions. Yes. Here we have in Germany something that is called Blue Angel. That is a label that is issued by the Federal Agency for the Environment, and to get such a product-based label, or in this case called Angel, what you see here, this Blue Angel, you have to comply with the criteria for that, for that environment-friendly shoes. What I could see, there are not many manufacturers until now who have this Blue Angel, but there are some. I only want to tell you that there is a high need and a high interest that the production of shoes will become very environment friendly. Here is a criteria from the Blue Angel, and you see that criteria is a little bit more strict as the 25 gram VOC in the VOC degree, but it's not so a big difference. It is 18 grams, and yes, for personal protection equipment it's 20 grams, and for some special shoes it is 25 grams. But the general value is 18 grams, for example, for street shoes. Yes, and there's a European eco-label for footwear, but I think there are not many installations or not many manufacturers who have this European eco-label. Here are the criteria. It is 18 gram too, like the Blue Angel. Yeah, so here are some case studies, but I will skip a little bit. I just can say as a summary here, many, and you have to look, there are differences. Many suppliers of HFCs for glues, they're offering meanwhile environment-friendly solutions. Yes, for example, I showed you Adidas. Now you see that was 2014. Say in 2014 they reached already 17 gram, and remember in 2003 they failed with the compliance. And 2016, you see they are now here, and probably I didn't check for the other years, but probably they reduced the VOC exposure much more. There is a concept of a green shoe that was presented by a conference from Bayer Materials. So Bayer is producing and offering a lot of environment-friendly HFCs. So here you see what the different parts, how they can make environment-friendly. So here there are different suppliers. I want to skip a little bit because of the time. Covestro is very interested to improve the environmental fingerprint. And here they presented, for example, a sustainable concept for the what's the woman like, the high heels here. And so you can see in most cases they are using water-based adhesives. I think that's a big progress. Yeah, Nike improved the performance a lot, and in the 90 years they had much higher, 340 grams per pair, and now they have no problems with compliance. So what you see, what they did, they analyzed exactly the processes. That is what I recommended too, to analyze what materials you're using for what of the different working steps. So they could see most was used for the priming and cleaning processes. Yeah, there are different suppliers. For example, Eastman, Henkel. So for a lot of different type of shoes, the manufacturers of such glues are offering solutions. Just because the time is now very short. Hot melt is a very important glue, and it is solvent free. So here is an example where that hot melts can be applied. Here's an example from Greco. Yes, and so you see there are examples from Frabo. You see here they have water-based and a lot of materials you can order in as a water-based substance. But you can see there are still VOC containing adhesives, of course, on the market, because from product reasons, not all can be substituted by water-based materials. Here's an example from a water-based material as a spray adhesive. You see VOC content less than 1%. Yeah, here it's the same. That's an famous Italian company. They offer, you can buy solvent-based and water-based materials, and so you have to ask your supplier what is the best solution for you. Yeah, so I will skip a little bit because that is examples from manufacturers. So what I told you, what can be a solution to, especially if you want to work more efficient, you can try to automatize your production process. So even by using, for example, cabins or conveyor belts and so on, that can help to improve your production, but of course it can help to reduce the VOC emissions. Here, an example of this direct soling. You see that's the injection. You have, for example, isocyanate and polyol. You put here, you have this form, and you have the upper, and you put that upper in this mold. It's called mold, and then the injection, the material comes in, and it automatically the sole is formed by if it's getting hard, and you have this assembly here together. In other words, you have a very clean process. Very clean if you substitute the VOC containing release agent, because you want to separate, of course, the polyurethane, and the cleaning of the mold by a low VOC containing agent. So here you see an example how it works. That is here you see the spray. Maybe this here. Before you use it, you have to put on by a spraying robot the VOC containing or not VOC containing release agent on this form. You can see it here too. Yes, another picture how it looks. Yes, that's the tanks of a polyol, and you see the upper here on the top, and then the robot, it's like a carousel, so it is like a roundabout. So if then if the mold is ready, this shoe, this upper will be put to the mold. It is closed then, and then the injection take place. Here you see it again, like it looks. So here the liquid is coming or is injected into the form, and it gives then really an assembly of the sole and the upper. Yes, and as I told you, low VOC release agents are available on the market. If you want to use a voice gas abatement, then it's important, as you can see, that you extract the VOC directly from the working places, because it's important that the waste gas volume are kept small. And probably you need something like a filter from the artists. One option could be an adsorption unit, but probably that is not really applicable, because you have a lot. You have to consider the plant safety. If you have catons and so on, it can maybe be a problem, but it's not necessary that it must be a problem. It can, but the adsorption technique is something that could work as a waste gas abatement. But the adsorption technique, of course, you don't destroy the materials, but then you get it back as a waste, so you can subtract it in the determination of the solvent of the total emissions. What is something where you destroy it are thermal oxidation techniques like RTO, and generally what is applicable here is something like a rotating wheel, like here. So you extract from all the working all working places the VOC gases, put them to that wheel. That wheel is turning, and in the first step you have the adsorption, and when it's turned, you have you put hot air on it, and the VOCs will then be desorbed in a very concentrated way, and they will be fed here to a regenerative thermal oxidizer. So you have a two-step process. And the reason is because the waste gas volume here maybe is very large and you have a high dilution. The idea is to concentrate up the VOC concentration, that something like a thermal oxidizer is applicable. So that is maybe the idea how it works. Okay, so sorry, I'm 15 minutes over my time, but I hope that I could show you what are the main impacts and the main emission sources by the footwear manufacturing. I hope I could show you how to elaborate such a solvent mass balance for the shoe manufacturing. I think it's not such a big problem if you take into account the points that I told you. And the best way is not to install a waste gas abatement system. That is only if you see no chance to reduce the VOC content in the materials. The best option is really, and there are a lot of suppliers who can help you because they are offering already low VOC materials. It is to change to low VOC materials. That is here the option number one.